But another thing that you'll probably want to do is interact with the region of interest manager. So there's a lot of commands that are relevant to this, but most workflows are probably going to involve some kind of open image, run analyze particles, get all of those ROIs, and then loop over them or something. So, there's thankfully nice, obvious naming. So add. So if you tell it to open an image and draw a perfect square in the middle of the image, you could then add that to your ROI manager. You can delete things from the ROI manager. You can select them. So you would say like select, and then the index would be like some number. So if you want to pick the first one, you pick 0. If you want to pick the second one, you pick that, right? And you can also like nest things. So you could say, count how many things are in the ROI manager, and then select the count of, which would pick the last one, for example. You can rename things. You can count them. You can reset. We covered that one earlier with just deleting everything. So you might have a bunch of ROIs that Fiji stores as these lovely named things, but you could write a little loop that says, well, for however many things in the ROI manager there are, go to the first one, rename it ROI hash or cell number, whatever you want to call it, nuclei number, plus, and then this is just a sanity thing because this starts at base 0. So I would call the first one ROI1. Sometimes I don't, because that does get a bit confusing when you're trying to pick ROI12. It's actually the 11th index one. So depending on how friendly you want to be to yourself when you're debugging it, you can do that. But that can be quite useful. So I said before that we can generate these lovely results tables, but how do you get them out into an actual spreadsheet or something useful, rather than just saving this thing? So the results table is base 0, and we use this command get result, where the string here is the exact title of whatever the column name is, and then this the row number. So if you wanted to scrape out the first row here, that's like the area, it would be get result area, comma 0. Does that make sense? So here, if I say I've opened the blobs example image, and I've obviously got all the ROIs. So for the number of results, that's the command that'll say that there's 5 things here. So basically 5 times. Go to the first row and get the area and print it. And then it goes to the second one, third one, etc. Right? So in reality, you're probably not going to do that. What you do is dump that into an array that you've created that's the size of end results. And then you can start kind of populating whatever, arrays. And then you would have a single print to summary file statement that says, iterate through those arrays, print area of, the 0th one, the 0th of mean, whatever you can do. So you can kind of then have a string that goes to Excel or your CSV output file that's kind of useful for you. It's not just got everything here as like big long lists. Because you might want to have channel 1's area and channel 1's mean intensity and channel 2's mean intensity. So if you wanted, you could totally just go select your image, channel 1, run measure on all the things, save this as a table, and then basically go to channel 2, clear this, print it again, end up with 2 spreadsheets you then have to open and find the mean column, copy that, put that into a new Excel spreadsheet, for example. Then you do it again. Then you have to scroll down your 57 nuclei that it found, copy that into Prism. That gets tedious. So if you do it kind of the work here, and you scrape all the ones into one big long string that's easy to use, it can be future use time saving. So what does that kind of look like? So we use these arrays sort of thing. So here's a generic blob image. And if we run analyze particles, we blurred it, thresholded it, got the binary image, run analyze particles, and you can see that there's all these ROIs. So we would, so the number of blobs is a variable that we define as end result. So however many things it measured is how many things it found. Since we create this mean array called, there's a new, mean array is the array name. It's a new array that's the size of the number of blobs, same with area. Then I have a loop that says, well, for however many things it found or n results, we then populate each of these two arrays with those two numbers. And then at the end, I print to the summary file, basically each one of those. It is a little bit more work, but as I said, it saves future you some time. So if we open up the blobs. So if we have this open, what do I want to do here? Blur it, threshold it. And then if I do analyze particles and I have this summarize text, then I get this summary window, but I also have a results window. And if I did this correct, there should be like 30 numbers. I'm finding one with that white background. But the point was that if I wanted to just get count and total area, I don't have a command that can easily get this window information. So there's a special command that you can use called, what is it? It's like ij dot rename results. So what you can do is you can say summary is the old name, the new name is called results. And Fiji in its infinite wisdom just goes, oh, okay. So if you go old name equals summary and the new name equals results. This isn't in the slides, just FYI. You'll see that the summary window closed, and now my results window has the same headers, count, average start, on stuff, and other windows. So I can then query that. But you can't query get summary, total, count, whatever. That just doesn't work. So that's a bit of a workaround that I've used to get that summary window into something you can query. Because if you don't need to actually measure everything individually, then it'll be faster if you turn off the individual results and say just print the summary file, and then at the end just convert the summary to that. That's a little trick. Another thing to save time, so if you don't want to measure everything individually, that takes time. It might only take like 100 milliseconds if you've got 1,000 images that goes out. Another way to save time is to run in batch mode. So we covered the batch macro before. Batch mode, you can set this variable, set batch mode to true, and it won't actually open the file to be visualized. It'll open the file into memory, but it doesn't actually show it to you. It'll be useful because it uses a bit less memory, runs a bit faster. It also isn't going to flash up like 1,000 images really fast at your screen. It can give you a bit of a headache sometimes. So that can be useful. Caveat is, over the years, I've come across a couple of commands and plugins that people have written that do require a window to be open. So you're probably going to be fine, but just know that there's a couple of times and edge cases where it needs a window open. And if you tell it, don't open windows, you're script. As I said, it's a couple of times I've experienced it in 10 years, but I was pulling my hair out to figure out why. You can, I'm going to say limited success, have this toggle on and off throughout your script. So you can technically turn it on at the beginning and then turn it off if you need to display something, but limited success is what I would say I've had with that. So kind of rely on it being all on or all off. Okay. For the next exercise, which is kind of a bit more realistic and a bit more code, This was a script that I worked on with a researcher many years ago now, but they were imaging zebrafish, and this is a blood vessel in a zebrafish that's developing, and it's really important. And they have nuclei, and they have the group developed the biosensor where it would shuttle from sometimes in the cytoplasm and sometimes in the nuclei and back and forth, so they could get information about when the cell was going to divide. And so sometimes it's in the nuclei, and the nuclei were labeled red, and sometimes it was. It's obvious in the nuclei. So the task was to kind of create a script that would run on a folder of images, find the nuclei, measure the nuclei intensity marker of the other channel, and the max intensity value of biosensor channel, and then report all that out to the spreadsheet. So that's what we did. And so now we have the next exercise is you've got to do it all again. No. It's not worth making you reinvent the wheel. So I run this scenario and oh no, the script file's corrupted. There's a bunch of code that's missing. So hopefully from the exercise, and I've given some hints with the documentation in here, but try and see if you can figure out filling in the gaps as to what's not working anymore. So any of these commented out the hash strings, you would obviously make sure you do the comment bit, but they are where code belongs. So if you open up the file that's in the example one, oh good. That's just my Fiji's having a moment. That looks better. Okay, so stuff at the top. And every one of these are replaced. And I've basically given the verbatim what things are trying to do. So defines input folder location to variable path. You know what that looks like. Open the file. If you haven't got into the other script, then you can pretty much populate these things with whatever is working before. Because as I said, and I'll say again, if you use same commands, you can just copy paste from one code to another, and it should work. But yeah, have a go at that. It's okay if you gave up, because a lot of the times, if you're finding like, you might find someone else's code on GitHub or something and take it and modify it. So it's more about being able to read the code. But to go through the first one here, I added the path variable with the get directory. Having this means that when you run the script 5 different times, you're not having to come in and actually manually change it. This is just going to pop up a dialog. So that's why I prefer to use that way. So we change that one. Here I need to open the file. So I run path with D. So here the master kind of counts for the loop that it runs through. Mainly because I use I in everyone. So that's one little bit. And then we had down here massaging the nuclei channel. So that's my code for blurring it. So we ran a mean filter. And then we had to print how many nuclei that it found. So I used the ROI Manager count because we had added it to the ROI Manager. So I knew that it was in the ROI list. And then down here, I was lazy and I stole most of these commands to populate the broken ones down here. Because this is going to be the same, right? So here in the red nuclei channel, we get rid of everything in the result window, select whatever nuclei we're up to, measure it, and then scrape the result area and mean and put them into these variables. So down here, I can select the green channel and basically do the same, except I'm going to populate, instead of the green or red max area, biosensor mean, biosensor max. So let me get that. And this is actually incorrect. I should have 0 here. And the reason we want 0 is because we're deleting the results list every time. So taking the first row is always going to be all we have. And then I had some stuff down here, which is I needed a variable for the nuclei. So this will tell me the image number because every file in the list I'm using Z, whereas every nuclei at times I'm using I. And then I printed with the summary file something like I just put all these ones that we collected into my string with summary file at the beginning. And if you ran it, you'll see the output has a bunch of spreadsheets, or one spreadsheet with a bunch of numbers in it. So I provided the answers, they're all there. But yeah, hopefully that we just covered that. So we encountered the dialog box before when we had the scripts generator, but sometimes you might want to have the user put in a number or something, right? So I've had different scripts over the years. Some of them you might want to say, for example, we were found the nuclei and then wanted to draw like a donut around the nuclei and see how many bacteria were close to the nuclei. So the user might want to define how wide that donut is, and so that you don't have to edit the script. And it's kind of nicer than saying, oh yeah, open the file, scroll down to line 412 and change that one number there, because chances are they'll stuff it up and then they come back to you to help. So if you just say, open up a text box, what number how big do you want it? And then you can get that information. So the dialog window lets you the script get user inputs, whether it's strings, numbers, arrays, multiple or single selections to help run it or configure how. So we use the dialog box. So first we create it, and you can put some kind of title. And then you would have if you want to add a string, you can say title equals, the title here, or if you want to add choices, you can have arrays, you can have numbers, you can have checkboxes, so like tick boxes, you can have radius buttons, or the whole thing, and then you show it. These should auto figure out. So if you don't put a number here, it's probably going to get cranky with you. This add choice is like a drop down, so you can have like a little selection.
The public default is maximum.
So this is the default. So after it here, you would have so in my script generator, I say by default the .tip. You can change that to whatever you want, but that's what it's populated. So good question. There is another dialog type that uses a different format, and it's called the @ string. And that you can get a bit more funky and define maximums. You can define different things as well. But I don't actually cover that in here. And then if you want, the user puts in stuff, you want to read out what the dialog information was. So it's pretty much similar commands, but instead of like dialog add a string, it becomes dialog.getString. And so you'd have like a variable that then would scrape whatever result they give it, the user's input. If you had two places where you ask for the number, then like the order of appearance in the script is how it populates. So here we have like width and height of both numbers. So you just write it in order. And if width was asked first, then it gets populated first. And you can always debug it by just testing it and printing out width and height and changing the numbers and seeing what order it gets. So in this exercise, I don't know the way how to deal with it, making it. So we've all done the projection. But if we were to recreate this little thing that we use all the time, probably every day, what code is required? So when you open an image, it always would put the default stop slice to be the number of slices. But you can change that, but you can put it there. It should K at the top of the box, the projection, and you should have a drop down with all the choices for the different projection types. If you have like a time series, there'll be a tick box that appears that says, do this to every frame. So let's try to come up with an idea of how to do it. So we're going to recreate this by doing the code to do this. When you run it, you do get a little error saying that like your script is running a script. Single function, just ignore that. But we can have a go at doing that with test done. So the first thing I had in the answer one was if the number of images open is equal to 0, i.e. there's nothing open, show an exit error saying there is no image open. But if there isn't no image open, then there must be an image open. So then we're going to L through everything else, right? So I get the dimension because we know when we open the Z project window, the stop slice is the number of slices. So we had to get that here. And then here I made an array called options, which were the different projection types. So we create our dialog box and we always start at slice 1. So I may as well type in there the default 1. And my default end will be however many slices I have. And then I add a choice dialog option where it's going to be one of these. So create the drop down list of all of those. And then I had within the dialog, I asked if there's more than one frame, then also add a checkbox project all frames. Because when you have more than one frame, it puts the checkbox there and it ticks it for you. That's why I say it's true. And then we show the data. Then it's going to scrape out the, what you entered into that, and then it's going to run. And here, I say if project all frames is true. Now that would only be the case if there was more than one frame and they left it ticked. Then run the Z project command with the projection type option, with the start slice and stop slice option. I need to scroll across because when I zoom in, it doesn't fit. And then we add this other flag for all because that's what Fiji interprets to do all frames. If I didn't have project all frames, so in other words, if this equals 0, then I just don't need to put the all at the end, right? But it's the same thing. So that's my logic there with how to do that. So it's kind of introducing a few concepts or confirming a few concepts, getting a variable, applying, creating arrays. This is new, but very useful having these options to toggle on and off things for your scripts. How to get scripts and then how to do something.